So this is worksheet 1, orbital diagrams and quantum numbers. As you're doing this worksheet, you're going to need a few things. You're going to need a periodic table for you to use, and you're going to need your quantum number notes. So I'm going to reference these as we go through this. So there's a few sections you're filling out. Atomic number, which is straight off the periodic table. It's your number of protons. And so you can see I already did hydrogen, which is 1. Helium is 2. Okay, that's the top number of the periodic table. Then we're going to draw orbital diagrams. Orbital diagrams represent where are the electrons located, and they use arrows and lines to showcase that. And then quantum numbers is we look at your orbital diagrams and we just use numbers to describe the location of those electrons. Now, why we need the atomic number is it's telling us how many arrows we'll actually be drawing in the orbital diagram. We'll only have one arrow. Okay, and it is going to help us through the rest of the pieces of this. So the first thing you need to know when drawing an orbital diagram is how do I figure out what's the sublevel and the energy level of that electron? So you'll have to be able to use this chart. So I'm going to show you how to draw this chart and then we'll use it. So let me get a blank sheet of paper. And you can draw this onto your worksheet itself. But if you remember, there's 4 suborbitals. There's S, P, D, and F. Okay. So how we draw this chart is we draw a series of numbers. So we start with S and we draw 1, 2, and I said draw, but I mean write. 5, 6, 7. Okay. The 7 comes from the periodic table actually. So 1, 2, 3, 4, 5, 6, 7. There's 7 possible energy levels. So we number 1 through 7 and we put an S next to it. For P, we start at the second level. So 2, 3, 4, 5, 6, 7. And we put P's. Now, I don't know if you're seeing the pattern here, but for D's, we're going to start at 3. And for F's, we're going to start at 4. And then next, what you're going to do is you're going to draw arrows going diagonal. Now, this may seem like a random diagram, but it fits along with the periodic table, and at another time we'll talk about how this works exactly with the periodic table. So if you're looking like this, we're going to use this to draw orbital diagrams. So according to Aufbau, we fill this orbital first, or the lowest energy orbital, and then we move on to the other ones. The thing you have to remember is that each orbital occupies 2 electrons. So when we're looking at the orbital diagram of hydrogen, we only need to use one of these because we only have 1 electron. So we start here, 1s. So what I do is I draw a line, and underneath it I write 1s because that's the first room we're looking at. Now remember I said each room can only have 2 electrons. So if we're looking at this, we're at 1 energy level, we're in the s suborbital level, and we only have 1 electron we can show. So we're going to write 1 here. There's only 1, and I draw 1 upward arrow. Okay. So that's our orbital diagram for hydrogen. We represented my 1 electron with 1 arrow. And I know I did that right because I have 1 electron and 1 arrow. When we're writing our quantum numbers, what we look at is all the information here. So the first quantum number is our energy level right here, which is 1. Okay. Our second quantum number is our sublevel. So if you remember your notes and you look back at them, each sublevel, depending upon the letter, is given a specific number. So S is 0. So I would put 0. Our third quantum number is our magnetic quantum number. So for S, there's only one orbital and the value, or the quantum number, is 0. So 0. Then our last quantum number depends upon the spin of the arrow. So the arrow is spinning upward here. So an upward spinning arrow is a clockwise arrow, and that is a positive 1/2. Now helium has 2 electrons. So again, we would look at our diagram. Okay, we're still starting at the top, 1s. So I'm going to write 1s. Now I have 2 electrons, and so I write 1s2. I draw my 2 arrows. But if you remember your rules, and if you're on Pauli exclusion, it says when you're drawing 2 electrons in the same space, you have to have opposite spins. Now in writing our quantum numbers, paper's crooked, we're looking at the last arrow we drew. So this is the electron I'm describing. Okay. So remember, the first quantum number is the energy level, so 1. The second quantum number is the sublevel, so S, which is 0. The third quantum number is our orbital within S, and remember, S can only have a 0 value. And then our last is, what direction is our electron spinning in? Since it's counterclockwise, it's negative 1/2. Okay. So let's do lithium. So we'll start the same way. Lithium is starting with the 1s, okay, and 1s2. Now you may be asking, I have 3, why did I write 2? Because it can only hold 2 electrons. So I'm going to draw my 2 arrows. Okay. Now, remember I have 3, so this is where that diagram comes into play. So I already filled my 1s. Now I need to go to 2s. So I write 2s. And I only have 1 electron left because I already drew 2, so I'm going to put a 1 here, and I draw the upward arrow. Okay, so again, we're describing our last electron. So the difference in here is our energy level is 2. Our sublevel, which is S, has the number 0. This orbital within our sublevel, there's only one option, so that's 0. And the spin on here is a plus 1/2. Okay. So let's do a harder one. Let's do the bottom one here, which is carbon. My paper's light. Okay, so carbon has 6 electrons. So we need to represent those 6 within this space. So we start with 1s again, and each line can only hold 2. So there's my 2 electrons, Pauli exclusion, right? And then we're going to move on to 2s, and can only hold 2, so we'll put our next 2. Now if we look at our diagram, after 2s comes 2p. So I'm writing 2p. Now why I left space is if you go back to your notes, p's always have 3 orbitals. What that means is when I write a p, I draw 3 separate lines. Okay? And I already took 4 electrons, so I only have 2 left, so 2p2. And that last rule, Hund's rule, tells us that electrons will individually occupy independent spaces before they pair together if they have the room. So we're describing this one. So if we're doing this, our energy level of this electron is 2. Since we have a p, if you look at your sublevels, p is 1. Now for your magnetic, so p has 3 orbitals. Depending upon which orbital it gets a different number. So if it's, let me try to put these together. So if the arrow is here, that number is -1. If it's in the center, the value is 0. If it's here, the value is 1. Okay, so since it's in the center, the value we give is 0. And then the last number is based upon the spin. It's spinning upward, so that's a +1/2. Now let me do one last one with you, and we'll do a harder one down here, which is, we'll do any is 10. So if we're doing any, we're going through the same process. We need to occupy or show where these 10 electrons are. So we start with 1s. Okay, there's only 2. Okay. And then next is 2s, 2. And then we have 2p. Draw our 3. Now each of these can hold 2, so 2, 4, 6. Right? And we're going to need all 6 because 2 + 2 + 6 gives me 10. So I put 1 arrow in each, and then I put them the other direction. Okay? And I know this is right because if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Now we're describing the last arrow. So quantum numbers. First one is energy level. So the last arrow is in the second energy level. It's in a p. So p gets the number 1. Okay. Now the location of this, remember, this gets a number of -1, this gets a 0, and this is a 1. Since it's in this last orbital, the number it gets is 1. Then since the arrow is downward, it's -1/2. Okay.